So today we're going to take a look at the intersection of some vector lines. So we're going to write down a couple lines first. The first one, we're going to have line A equals negative 1, 6.
The building leadership meeting is starting now
plus
in the media center classroom.
R times negative 3,
Hope to see you soon.
2. We're going to have line B equal to 0, 2 plus 1, S times 1, 1, and line C equal to negative, oops, let's not do negative 10, let's do positive 10, 3, plus negative 2, 3, T. I could have put that T beforehand as well. So the first thing we're going to do is find the intersection of A and B. We're going to do this first one graphically. So the first thing that we are going to do is we're going to make a nice graph here. Okay, so we're going to graph A and B. So negative 1, 6. Negative 1, 1, 2, 3, 4, 5, 6 would be right here. And then our directional vector is negative 3, 2. So we go, oh, my bad. That is supposed to be 3, negative 2. So we go over 3, 1, 2, 3, down 2, over 3, down 2, over 3, down 2. And we have our first line here. And our line B starts at 0, 2. And then we go over 1, up 1, over 1, up 1. And we can see it intersects right there. So that's the coordinate 1, 2, 1, 2, 3, 4. So our answer would be 2, 4. Now sometimes our lines might get too big to graph here. So we're going to take a look at how you find this algebraically. So let's find the intersection of B and C. Now B and C have the same x value and same y value somewhere. So we're going to write this out. We're going to see what are our x components and what are our y. So if we go back up to B, the x component, 0 plus 1s. So 0 plus 1s. And that y component, so the y would be this bottom part. So we have 2 plus 1s. And then we can do the same thing for our C line. So our C line, we have 10 minus 2t. And then that y part would be negative 3 plus 3t. Now if you guys remember, this is a system of equations we're going to solve. So we have our variables stacked. We need to make one the opposite. So I have positive 1 and positive 1. So I'm going to multiply this whole thing by negative 1. So our top line stays the same. The bottom one would become negative 2 minus 1s, 3 minus 3t. So if we add these together, we have negative 2, 13 minus 5t, minus 13 minus 13, negative 15 equals negative 5t. So they intersect when t equals 3. Now that's not our intersection point, that's our t value when they intersect. So now we have to plug that back in for t. So our x would be 10 minus 2 times 3, and our y value would be negative 3 plus 3 times 3. So let's see, 10 minus 6, so that gives us 4. And negative 3 plus 9, that gives us 6. So the intersection point is 4, 6. Intersection of lines A and C. So we'll do this setup the same way. We'll write our x components and our y components. So why don't you pause the video, see if you can find the x components and y components, and then start it once you have those. So our x component, so we should have negative 1 plus 3r. Double check that. Yep, and then we should have 6 minus 2r. Why did I put a t there? All right, and then for our c, we did that above. So we have 10 minus 2t, and then we have negative 3 plus 3t. So again, we have to make these opposites, and none of them are direct opposites. So let's pick r's or t's, and I'm going to choose r's. So 3 and 2 go into 6. So I can multiply this one by 2, and I'd have negative 2 plus 6r equals 20 minus 4t. And then this one, if it's positive 6, to make it negative 6, multiply by 3. So I'd have 18 minus 6r equals negative 9 plus 9t. Add these together, we have negative 16, so that would be positive 16 equals 11 plus 5t minus 11 minus 11. So 5 equals 5t. So they intersect here when t equals 1. So again, if we plug that back in for our t, we have 10 minus 2 times 1, which is 8. Negative 3 plus 3 times 1, which is 0. So they intersect at 8, 0. All right, and the last thing we're going to do is we're going to look at one in 3D, and we're going to see how this is just as easy. So let's say we need to find the intersection of these two lines, and R is negative 3, 0, negative 1, plus 1, 1, 1, S, and line W equals 6, 2, 0 plus t times 0, 4, 8. All right, so instead of just two components, we have three. We have x, y, and z. But we can write those out. We got negative 3 plus 1s, 0 plus 1s, negative 1 plus 1s, and then we have 6 plus 0t, 2 plus 4t, 0 plus 8t. And now for elimination, we could choose any of these. We only need to choose two lines. So maybe I'm going to choose y and z. And maybe I want to eliminate the t's. So if this is 8, I could multiply this by negative 2 to make it negative 8. And again, you could eliminate the s's. It really doesn't matter. You'll get the same thing. So we have 0 minus 2s equals negative 4 minus 8t. This bottom one can stay the same, plus 1s equals 0 plus 8t. So we add these. We have negative 1 minus 1s equals negative 4, plus 1 plus 1, negative 1s equals negative 3. So s has to be positive 3. But then we have to plug it back in for all of our s's. So negative 3 plus 1 times 3, well, that's 0. 0 plus 1 times 3, that's 3. And negative 1 plus 1 times 3, that is 2. So it intersects at the coordinate 0, 3, oops, closed it early, so used to closing that parentheses, 0, 3, and 2.